Internal resistance is generally seen for a battery. So it is said that for a battery, it has these terminals plus internal resistance. When we talk about the battery box, then battery box comprises of both the things. Okay. Because of this internal resistance, the net supply by the battery is always less than what it is written on it. Okay. So the net
Okay.
potential across the battery, let's say if this is V, okay, and this potential across the terminal of the battery we can consider as E, and internal resistance is R, then we can write V is equal to E plus IR. V, net potential across the battery, is equal to E plus IR, where E is referred to as EMF of a battery, electromotive force, I is the current, and small r is the internal resistance. So all we can say is that the EMF of the battery, okay, the EMF of the battery is generally what? The one which is written. Okay, for example, if it is written 10 volt on the battery, okay, so EMF will be 10 volt. And if we have to see the net potential across this, okay, so one thing, if I'm talking about the net potential, okay, so net potential in the direction of current, the direction of current will be like this only. So in the direction of current, there is always a voltage drop across the resistor. So there has to be a minus sign we have to put over here. Okay, just change that. It will be E minus IR, because how you will understand that if EMF of the battery is 10 volt, then it will never supply exactly 10 volt. It will supply somewhat less than that, let's say 9.9 or anything in that range. It depends on how much internal resistance it has. So because of that internal resistance, the net supply by the battery is always reduced. Okay, and this is a formula which we can use for questions. Why it is E minus IR? Because if you look at the terminals of the battery, let's say if this is a circuit, okay, so the direction of current, if you notice, it will always be from the positive terminal to the negative terminal. It means that when the current will come back, so it will go in the resistance also. So in the direction of current across a resistance, there will always be a potential drop. Okay, there will always be a potential drop in direction of current. If we are talking just opposite to the direction of current, then we can write it down as plus IR. So generally, whenever we move in a circuit, this will be used in DC circuits also. So when we move in a circuit, then we take potential drop. So that is represented by a negative sign.